mapagpala, mapagpalaya at magandang umaga ang Bataan! Siyempre, good morning to you, Ma'am Jaisa, and to the rest of the senior high school team. Magandang umaga to all of our teacher participants from different senior high school science departments from all over Bataan. And ALS na sumusubaybay ngayon sa DepEd Bataan Facebook page and our very own Bataan Science channel sa YouTube. Kung ang mga sci-fi nga ang may trilogy, siyempre hindi papahuli dyan ang DepEd Bataan Science Department. This is our finale session of our 4-part year-long division webinar series on science content and teaching strategies for senior high school tackling 4th quarter science competencies. Oh, kumusta na ba ang lahat? We hope the energy from our breakfast takes its effect dahil need natin ng dagdag na fuel para mas ganahan pa tayong matuto at magkaroon pa ng marami pang estratehiya sa pagtuturo. I am Sir Miggy, science teacher from Samuel National High School Senior, one half na pinagsanib puwersa moderator this morning. Ma'am Jaisa?
Good morning, Sir Miggy, my partner for the second time around, to the whole program management team, and of course, good morning to all the viewers of this webinar. I am Ma'am Jaisa, teacher 2 of St. Francis National High School, one of your moderators for this morning. We are now down to the last quarter of our webinar series, and we have learned so much from the previous webinars, and this morning is no exception. Alright, so let us now formally open our program this morning. Grade 11 and 12 Science and Arts teachers, SDO Bataan, welcome to the Division Webinar Series on Science Content and Teaching Strategies in the context of the most essential learning competencies for the 4th quarter. Let us first have an audiovisual presentation of a prayer to be followed by our national anthem.
Our Heavenly Father, the fount of all goodness and grace, the cause of wisdom, the source of intelligence, we welcome you, O Lord, to this auspicious gathering of your beloved, who continuously give you thanks for every opportunity to learn something new and become fruitful to the works of your creation. We humbly come to you, not because we are worthy, but because we find ourselves in need of you, who is our strength and our hope, to continue despite the challenges we face in health, prosperity, and our solidarity with one another. We pray that today's gathering, made possible by the grace of advancements in technology and social media, becomes successful in its endeavors, so we can offer it back to you as our humble offering to honor you, glorify you, and love you through our deeper connection with everyone. May we find bliss in today's session and become more productive children and co-creators of the earth. This we ask and pray through Christ our Lord. Amen.
Ang pambansang awit ng Pilipinas. Kayang mag-ibig,
morning again to our inspired teachers, audiences na ngayon nanonood ng ating Division Webinar Series. This webinar series is made possible from collective efforts and support from each and every one of us. And speaking of efforts, let us welcome the mastermind behind this webinar series. Our hardworking and ever-motivating education program supervisor for our sciences, Dr. Edwin Riel Bermilio. Magandang buhay po, sir.
Magandang buhay po sa lahat. Welcome to the last wave and leg of our division webinar series on science content and teaching strategies in the context of the most essential learning competencies for the fourth quarter. Sabi po ni Henry Ford, coming together is a beginning, keeping together is progress, working together is success. And I believe that this highlights the importance of working together in teams for science department from first to fourth quarter of its activities. With this, I would like to personally take this opportunity to express our sincerest gratitude for the success of all our science webinar series. To our school's division superintendent, Dr. Roland M. Fronda, to our assistant schools division superintendent, Sir William Roderick R. Falurin, words can neither qualify nor quantify how helpful your guidance and advice has been. We are forever grateful for your support sa Science Department. We continuously learning from your examples because your leadership is not just about titles or positions, it's about one life influencing another. Thank you po, Sir Roland and Sir William. To our Curriculum Implementation Division Chief, Dr. Milagros M. Peñaflor, thank you for your trust and confidence. Your support and guidance have been instrumental in helping us to provide quality science curriculum instruction by enhancing the content knowledge and pedagogical skills of our science teachers, including alternative learning system from grades 3 to 12. To our public school district supervisors, science department heads and coordinators, and our elementary school principal coordinators, our sincerest thanks for selfless support in all our endeavor. Your dedication, compassion, skill, and professionalism will allow us to get through all the activities with flying colors. And we are all indebted to you. We appreciate your sacrifices to be at work. We want you to know that your actions are seen and appreciated. To our team leader and assistant leaders per grade 11 who had been working countless hours to make sure that everything is okay. Sabi po ni Mother Teresa, God does not command us to do great things. God commands us to do little things with great love. Not all of us can do great things, but we can do small things with great love. Maraming salamat po sa pagmamahal. Amidst the challenges, I am also very grateful to have our intelligent, strong, competent, and brave resource speakers who took the challenge as learning facilitators. Thank you for great performance, dedication, and expertise in delivering quality instruction to the teachers and learners of the SDO Bataan. Of course, special thanks to the members of the program management team in charge for online platform, program design, Google Forms, and our moderators for the hard work and for silently working behind the scene just to make sure that we have tools and resources available. We value all your dedication to keep us up and running. Your efforts are truly appreciated. To our science teachers, we hope that the trainings we have provided will help contribute, improve students' learning outcome, develop strategies and approaches, and encourage quality implementation of science curriculum and implementation. From the first until this fourth quarter webinar series, your individual commitment to a group effort is what makes a science department. Maraming salamat po sa lahat. God bless us all.
Thank you to our ever-supportive and hardworking EPS in Science, Sir Edwin Bermilio, for that warm message. At this point, let us welcome our next guest. She is one of the most hardworking and passionate core members of the STO Bataan. She is always supportive and very generous in sharing her precious time with us. Let us hear it from our CID Chief, Dr. Milagros M. Peñaflor.
Today is your last among the 4 webinar series of this kind in science. I am glad that you all were able to make it. Congratulations to everyone, my dear science teachers, department head, principal coordinators, and to Sir Edwin Bermilio for the untiring efforts in bringing a quality science instruction to our young people amidst the challenges. We are now on the 4th quarter. It's like that we are ending the school year, but most of the wrapping up activities will be in this last quarter. The remediation, the catching up activities, plus of course, the readiness of our learners for the year-end assessment. Let us see to it that all competencies reflected in the most essential learning competencies are learned by our students. The provincial government, in line with the development of the Human Index, would like to measure how our schools perform, how our learners fare, considering the implementation of the learning continuity plan of our schools. I know that it is really hard to cope up with the many challenges, but I have seen how you did it with so many times with the issues and concerns in science. The challenges lies not only with our learners having the competencies, but how we make them critical and creative thinkers. Today's session hopes to deliver both, as our competent speakers dwell on interesting topics, putting premium on the plight of our teachers in teaching the skills, how this could be a ready hand for teaching lifelong learning skills in science. Thank you for everyone's participation in this webinar. Thank you for your resiliency in pushing through up to this last quarter. Thank you for keeping up with your promises para sa bata, para sa bayan. Happy day, happy learning, and God bless us all.
Dr. Bermilio is the mastermind of this very successful webinar series. Mamila is the heart of it all. Thank you, Madam Chief, for your never-ceasing support. And to complete this morning's opener, let us hear the message from our OIC Schools Division Superintendent, Orlando M. Frondas, CESO 6. Magandang buhay po, sir.
Good day to all the participants in the webinar series on science content and teaching strategies in the context of most essential learning competencies for the 4th quarter for grades 3 to 12 in SDO Bataan. We are nearly 1 month to go before the closing of school year 2020-2021. And we have hurdled, we have surpassed, we are survivors. This event likewise culminates the webinar which the division have initiated from the 1st quarter up to the last quarter. And I am certain that what we have experienced from the time we started this uncertain and ambiguous journey, it has taught us a lot of lessons how to cope with all these challenges. In our present system and practices in education, particularly in these trying times of uncertainty, many of us would surmise that our education systems are not well aligned with the overall goal of learning. Other goals can detract from, and in some cases compete with, efforts to improve learning outcomes. We could also infer that the elements of an education system are often incompatible or incoherent. For example, our government funding allocation sometimes fail to provide the resources schools need to improve learning. And even the school funding is available. The rules governing its use often leave little flexibility for schools to use it in ways tailored to specific needs of students. What we can do is to become resilient. No, it's resiliency is actually the byword of the pandemic. No, to promote resiliency, no, as science teachers, no, we must consider our strengths and our assets in education communities and systems to support our students in making sense of the adversity they experience. I know that it's not only the students who are experiencing adversity, but also our teachers, our school administrators. We should find the very purpose in education and develop the needed skills and competencies. We need to upskill ourselves as well as teachers. Your collective participation in this kind of academic exercise can propel our mutual support and commitment to learning, because protection and well-being of our students, our staff, and our families that are affected by this great educational challenge is paramount. Well, to put emphasis, resilience matters because not only is learning and school success possible in spite of adversity, education can also be the vehicle to overcome the adversity. To Dr. Peñaflor, our CID chief, to Dr. Bermilio, and to all the participants, thank you very much for sharing to us your precious time to actively participate in this kind of activity, this half-day activity. I believe this will end until the Friday of this week. I hope all your sharings of experiences would give us feedback to calibrate and redirect our compass what to prioritize, because we value your observation, we value your inputs and recommendation to better improve our service. We want to make sense and find our purpose that in turn will allow us to make meaningful and positive decisions as we mold heroes in Bataan. Magandang araw po sa ating lahat. Pagpalain tayo ng dakilang Diyos at patuloy po kayong mag-ingat.
Thank you to our very supportive OIC Schools Division Superintendent, Sir Roland M. Fronda, for sharing your kind words and precious time with us despite your busy schedule. And with that, I think we're now ready to proceed to the most important part of our webinar, the showcase of knowledge in content and strategies in teaching science. Let us now have our first facilitator. She is a graduate of Master of Arts in Education, major in General Science at Bataan Peninsula State University. She is at her 4th year in teaching senior high school and a teacher 2 at Orani National High School. To discuss the topic Properties of Light, let us welcome Ma'am Shermine D. Atienza.
Good and blessed day, everyone. I am your first facilitator for today, Teacher Shermine Atienza de Guzman of Orani National High School, Maine. And I am about to give you a clearer discussion about the wave properties of light. So this presentation is intended to tackle our most essential learning competency, which is to differentiate dispersion, scattering, interference, and diffraction of light. With the code S11/12PS-IVH-65. So this competency is also one of the least learned competency in physical science. So I hope at the end of this discussion, you will have better understanding about these properties of light. So, we know that light is a wave and a particle at the same time. So, as a wave, it can be dispersed, scattered, interfered, and diffracted. First property is dispersion, which is defined as the separation of white light into its 7 color components when passing through a transparent medium like a glass prism. So dispersion happens when there is a refraction. Remember that refraction is a bending of light that passes from one medium to another. That causes a change in speed. It slows down when passed through into a denser material and faster in a less dense material. Again, the splitting of white light into its constituent colors is called dispersion. It was Sir Isaac Newton who first discovered that ordinary white light is a combination of colors. This band of colors produced is called spectrum, and the name Roy G. Biv is an easy mnemonic for remembering the colors of this spectrum. White light is composed of different colors of the spectrum, and each color has its own wave frequency. As you can see in the image, different light frequencies bend at different amounts when they pass through a prism. It refracts 2 times, making the separation of the colors noticeable. That causes dispersion to happen. But how does a prism disperse white light? Sir Isaac Newton performed an experiment to show that white light consists of a band of colors. A white light ray is passed through a prism to split it into the colors of the spectrum. The different colored light is allowed to pass through an identical prism kept in an inverted position. The light emerging out of the second prism was found to be white, indicating that the light ray consists of colors. One spectacular example of this is a rainbow formation, which is a natural appearing in the sky after a rain shower. And it is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. Water droplets act like a small prism. They refract and disperse the incident sunlight, then reflect it internally, and finally refract it again when it comes out of the raindrop. So, it was René Descartes who first gave a detailed explanation of the formation of a rainbow through mathematical tracing the path of light in a spherical drop of water in 1637. And due to this dispersion of light and internal reflection, different colors reach the observer's eye. Have you ever wondered why the sky is blue? The sun is red-orange, and the clouds are white. All this will be explained by another phenomenon associated with light scattering. Light scattering is the ability of particles to absorb light and scatter it in all directions. Our atmosphere is composed of tiny particles that scatter the color components of white light. The atmosphere has an abundance in nitrogen and oxygen particles, which can scatter higher frequency components of white light. They scatter violet the most, followed by blue, green, and so on. The scattering of light components depends on the size of the particles or scatterers. Small particles scatter components of short wavelengths. Larger particles scatter longer wavelengths. And we have two types of scattering. First is a selective scattering that is called Rayleigh scattering, which is named after the 19th century British physicist Lord Rayleigh or John William Strutt. Rayleigh scattering explained why we see blue sky. So as light moves through the atmosphere, most of the longer wavelengths pass straight through. Little of the red, orange, and yellow light is affected by the air. However, much of the shorter wavelength light is absorbed by the gas molecules. The absorbed blue light is then radiated in different directions. It gets scattered all around the sky. So since our eyes are most sensitive to blue frequencies of light, we see the sky as blue. Rayleigh scattering also explained why we see red or yellow color of the sun. After much of the blue portion of white light spectrum is absorbed by the molecules in the atmosphere, the rest of the spectrum continues its journey. So since the blue element has been removed from the spectrum, the remaining components combine to appear yellow or golden to the naked eye. Another type of scattering is the mist scattering. Clouds appear white because the water droplets in the clouds are larger than the wavelength of light, which scatters all the colors of light equally. So as a whole, we can say that the light is reflected in many ways, which combines to give white color. Next property is diffraction. It is the bending of light when it encounters an obstacle or an opening, and it forms a shadow when light meets an obstacle. The bending of light is not very much noticeable, but when you look around the edges of shadow, you will notice blurred areas. And these blurred areas are what we call diffraction fringes. So these areas where the diffraction of light occurs. So the effects of diffraction of light were first carefully observed and characterized by Francesco Maria Grimaldi, who also coined the term diffraction. So from the Latin diffrangere, which means to break into pieces, referring to light breaking up into different directions. The amount of diffraction depends on the size of the obstacle. As you can see in the image, the bigger the opening, the smaller its diffraction effect. And the smaller its opening, it resulted to a larger diffraction. The amount of diffraction also depends on the wavelength of light. As shown in the diagram, the longer the wavelength, the greater is the diffraction of light. The effects of diffraction can be regularly seen in our everyday life. The most colorful examples of diffraction are those involving light. So for example, we have the rainbow patterns on CD, the diffraction in the atmosphere, the speckle pattern in laser light, and the gaps in the door. So the closely spaced tracks on a CD or DVD act as a diffraction grating to form the familiar rainbow pattern we see when looking at a disc. So recorded data on CD is stored in microscopic pits of different lengths which carries information in the CD. These pits are placed in a row of the same width and at equal distance. This forms a diffraction grating on the CD mirror surface. Diffraction in the atmosphere by small particles can also cause a bright ring to be visible around a bright light source like the sun or the moon. This halo effect or a lunar halo is caused by light rays diffracting around the moon. Next is the speckle pattern that is observed when laser light falls on an optically rough surface is also a diffraction phenomenon. Last, the door is playing the role of an obstacle in the path of light wave here. And light waves can enter a room through gaps in the door. And these gaps are acting like secondary sources of light wave. So when you turn off your room's light in your house and lights are on in another room, you definitely have noticed light coming in your dark room. But what if we close or slightly bend the room door? Well, even after that sunlight can enter in your room, but the door is not being able to fully cover you up, there is some gap in the door through which light can enter inside the room. So this is also one of the daily life examples of diffraction. And all these effects are consequence of the fact that light is a wave.
Young's double-slit experiment. Interference in light waves.
So next property is interference. Interference is the result of superposing of waves from different sources. In order for us to understand it better, let us watch a video clip of a double-slit experiment made by Thomas Young.
From two sources was first demonstrated by Thomas Young in 1801. A schematic diagram of the experimental setup is shown here. Light was made to pass through a slit, SO. The waves emerging from this slit was made to pass through two parallel slits, S1 and S2. These two slits served as a pair of coherent light sources because waves emerging from them originate from the same wave front and therefore maintain a constant phase relationship. Thomas Young observed that the light from S1 and S2 produced on the viewing screen a visible pattern of bright and dark parallel bands called fringes. What causes bright and dark fringes? A bright fringe appears if the light emerging from S1 and S2 interfere constructively, and a dark fringe appears if the light from the two slits combine destructively at any location on the screen.
So as seen in the clip, there are what we call fringes on the edge of a shadow formed by the diffraction of light. These fringes or the interference of light waves are the result of the diffraction of light at different sides of the object or obstacle, which causes the shadow to be fuzzy. When this property was observed in the visible light, it was considered as a clear proof of the wave nature of light. So light waves may interfere constructively or destructively. Constructive interference happens when two identical parts of two waves meet, such as a crest of one wave meets the crest of another wave of the same wavelength. And this would result in a new wave with the same wavelength but twice the amplitude. While destructive interference happens when two opposite parts of two waves meet. For example, a crest of one wave meets the trough of another wave, which would result in the cancellation of two waves. So as the wave from these two openings meet, they interfere and produce interference patterns. The bright fringes are the areas where the waves interfere constructively, and the dark fringes are the areas where the waves interfere destructively. So now that the differences between each property of light have been discussed, let us now have a short activity. So get your pen and paper or any material where you can write your answer. Are you ready? First activity is a matching type. You're going to arrange the jumbled words in column A and match it with column B. You're going to write the letter of the correct answer on the space provided. I will give you 30 seconds to finish this activity. Okay, time's up. It's time for us to check your answers. Congratulations! Let's now proceed to activity number 2. Are you ready? Our activity number 2 is concepts in a box. We're going to complete the concept map using the words in the box. I will give you another 30 seconds for this activity to finish. Time's up! So let's check your answers. Congratulations! Okay, so these are the references that were used in this presentation. Okay, so I hope that this discussion had helped you to have better understanding on differentiating dispersion, scattering, diffraction, and interference. So that's all. Thank you and have a good day.
Ayan. I guess at this moment, na-enlighten na tayo sa mga tinuro sa atin ng Teacher Shermine. Oh, enlightening na ba ang properties of light? I guess so, para kapag pagbalik ng face-to-face class, may bago na naman tayong technique. Thank you, Teacher Shermine. And for the next discussion, ay nakalaan lamang ito para sa mga single. Oh, kidding aside. For the next discussion, we'll be having the physics, one of the challenging ones, the single slit diffraction. Let us welcome the Master Teacher 2 from Balsic National High School, Ana Belen S. Bernaldo. Good morning po, Teacher Ana.
Hello everyone! Welcome to our General Physics webinar. This is Mrs. Ana Belen S. Bernaldo, your facilitator for this session. Thank you for being with me for the next minutes. COVID is still here with us, so we have to deal with it. But while staying home with our family and carrying out our roles as teachers in a non-face-to-face scenario, we still have to continue sharing ideas not only for today's use but for future references too. Sabi nga nila, the show must go on. My topic is all about single slit diffraction experiment, where we shall take it second semester, quarter 4 and week 9 based on our most essential learning competencies. The content is standard. The learners demonstrate understanding of diffraction from single slits. For the most essential learning competency, we have relate the geometry of the diffraction experiment setup, the slit size and screen to slit distance, and the properties of light, which is the wavelength, to the properties of the diffraction pattern, width, and the location of intensity of the fringes. We will study the relationships among these factors. Basically, this will be answered and key concepts will arise. Specifically, answering these two questions. First, what will happen if the width of the slit is increased, is decreased? And number 2, what will happen if the wavelength of the light is increased, is decreased? To start with, here is a 5-minute video clip. And if we haven't used this yet, sooner as we start with this lesson, we can simply present it to our students, and if we go back to our face-to-face lessons later, it can be improvised too and be demonstrated inside the classroom.
Today, I will explain here a simple experiment to demonstrate diffraction at a single slit. All of you know what is diffraction. Diffraction means bending of light rays around an obstacle and spreading light waves into the geometrical shadow. And to demonstrate this diffraction experiment, we need very simple things. We need a can like this with a plastic lid and a laser light. You can use a green or red laser light. And first of all, we have to make a slit for the experiment. That is the main part of the experiment. To make the slit, remove the lid, and on this lid you cut a small slit, a small aperture by using a sharp aperture by using a blade, and opposite to that fix two blades like this, okay, parallel to the slit. Fix one blade here. You can fix the blade here by using a cello tape and another piece of cello tape here, leaving a small gap in between the sharp edge of the blade over here, so that through the sharp edge of the blades, gap between the edge of the blades, we can pass light. You can see the light going up and down. That is a small gap between the two sharp edges of the blades. Very small gap. You need a gap of a hair length. A small hair gap is required. That is the slit we made here for producing diffraction pattern. Now, on this can at the back side, we can make a hole like this, so that through this we can insert the LED. Okay, this way, and the front side we can cover with the lid. On the lid we have the slit made by using two sharp edges of the blades. Fix it like this, and for keeping the laser horizontal, we can use some support here. Keep it horizontal and switch on the laser. When the light is allowed to fall on the screen over here, we can see on the screen, normally we expect what? When light is passed through this slit, we'll be expecting on the screen a thin, narrow image, illuminated image of this opening. But what we will be seeing, at the center, a wide and bright image of this slit, and on either side, this side and this side, on either side of this, means the geometrical shadow of these two sides. We can see bright, dark fringe pattern formed due to the diffraction. When the light waves bend around these two sharp edges of the blade, and since the light waves consist of secondary wavelets, the wavelets will spread around this obstacle, and when two wavelets with the crest and crest combine together, superimposed together, that area will become brighter, and crest and trough are coming together will become dark. So we can see on either side bright and dark image of the slit, even in the geometrical shadow. I will show you that after switching off the light. Okay, now you can see here, at the center there is a bright image of the slit with a double width here, and on either side of that we can see dark and bright fringes. So even the light is spreading towards the geometrical shadow on either side. And the experimental setup you can see here. This is the overall experimental setup. We have the laser light at the back side and the can, and the front side of the can there is the slit. The light is passed through the slit and it is falling on the screen. On the screen it is forming the fringe pattern with bright and dark fringes. Okay, thank you for watching this video.
To continue, for the next two slides, which is changing the slit width and changing the wavelength, are actually from a simulation activity I had just watched, but unfortunately, upon opening it again, I could not open it anymore. But I had taken screenshots of this. Buti na lang, alis tong konti. On this slide, we can see that the question posted asked our students what will happen if the width of the opening is increased. And we can add for the question, how about if the slit is decreased? There are three options to choose from. Letter A, the central bright region will get wider. B. The width of the central bright region decreases. And letter C. The width of the central bright region is unchanged, but brightness will increase. If I will be asking you these same questions, what will be your answer? Okay, next, on the other hand, changing the wavelength. On this figure, we may ask our students the effect of changing now the wavelength as what will happen if the wavelength of the light is increased. Three choices again were cited. A. The central bright region will also get wider. B. The width of the central bright region decreases. And C. The width of the central bright region is unchanged, but brightness will increase. I never regretted losing the link of the simulated activity, this simulation activity, since I still had found another. Therefore, we can still show our students another interactivity wherein they themselves can do the manipulations. In this simulation, we can vary the factors, and we can see right away the answers showing relationships of these factors for a diffraction to occur. We have here about the manipulations for wavelength, slit, angle, for maxima and minima and its relative intensity. It can be presented too in two ways, the diffraction pattern and intensity profile. Just click the button for this to show varied patterns and profiles. This will let our students to enjoy more and learn physics better. So, here is a diffraction of light by a single slit simulation. You would see here the given are, we have the wavelength, this is 380 nanometers, and of course, this is for what color? You can see that is for the violet color. So the wavelength of violet, as we can see here, is 380 nanometers. And slit width, this one, is 500 nanometers. Therefore, if you would compare the wavelength and the width slit, there is a greater width slit compared to the wavelength. And given also is the angle, and you can consider here maxima and the minima, and you would see here relative intensity is 1. If you are going to your mark here and touch this button, this one will now be showing you another set of data, and this is the intensity profile. Going back here, that is now the diffraction pattern. So, you are going to change the wavelength, say for example, move it like that. So, if you would see here, it's now changed to a blue color. Then the slit width is still 500. If you are going to change this to a higher width slit, 1300 nanometer, you would see that there is already a difference in what is shown here for the diffraction pattern here. And then if you change this to intensity profile, you would see this is the intensity profile for such an example. I have here a printed sample of data summary using the given and some answers. You would notice here the relationships among wavelength, slit, and angle. The maxima, minima, and relative intensity are also found here. How about the diffraction pattern and intensity profile? I will let you see also as printouts for the last part of my discussion. Hello again, fellow physics teachers. Are you still with me? I hope so. Now, this part of my discussion shows the condition for a maximum and for a minimum, its formula and the given factors or conditions. If you would see on the table, there is the formula in the blue box and the different conditions or the factors. We have the width of slit, the angle, order of the maximum, and wavelength. On the next slide, for a minimum, the conditions are also cited back to back with the formula. I will not discuss this further since my topic is only on the relationships of the simulation strategy with the video lessons that I had presented, but this lesson can be taught in many ways. And lastly, these are the printout from simulations. The first one, this is the diffraction pattern and intensity profile for violet. The wavelength here is 380 nanometers and the slit width is 500 nanometers. The next printout from simulations, this is the diffraction pattern and intensity profile for blue. The wavelength is 460 nanometers and the width slit is 500 nanometers. Next, we have the printout from simulations of the diffraction pattern and intensity profile for violet. Here, there is an increase with slit. The last printout from simulations, it is the diffraction pattern intensity profile for violet, increased angle. So, yan po ang mga pictures taken from the simulation relating slit, wavelength, and diffraction patterns. And we can now answer the two questions I had posted a while ago. And to summarize, number 1, if the width of the slit is increased, the width of the central bright region decreases. 2, if the wavelength of the light is increased, the angle of diffraction is also increased. These are the links and references I had used for my discussions. Oops, I'm not yet done. There's more. Alright, we move on to the next and last part I had prepared for you. In these preceding slides, let me present what I had gathered. There are 50 innovative teaching methods in science, pero in passing ko lang po sila i-discuss sa inyo. Yun lang pong ginamit ko sa pag-discuss kanina about diffraction ang i-discuss ko further. According to this, students' engagement and understanding of materials is given more emphasis in today's education over spoon-feeding, advanced ideas, and virtual teaching scenarios. This can help to build a better understanding of subjects amongst students. More than just conveying facts or findings in science, students will love to explore the world of science. These innovative teaching methods can substitute the typical teaching techniques to achieve the goal. So, let us see what is in store in it. But which did you think was the method I used to teach my lesson a while ago? Did you notice which group did it belong? If you guessed it right, it was in group 21 to 30. You are right. My teaching strategy used was multimedia approach. As stated, multimedia approach is a blend of text, audio, animation, video, still images, or interactivity content forms. It can convey vast information using advanced media, devices, and techniques, and involve a wide range of activities to provide a meaningful learning experience. From my lesson, the interactivity content I had used is simulation. In Tagalog, it means kunwari, an imitation or process produced by computer mode of something. This is also known as VIS, Virtual Interactive Simulation. Video clips in particular are part of this multimedia approach too. This technique uses instructional video clips available online or in libraries to show and teach a new online concept. Conveyed better with animations, it can also be videos of demonstrations of an idea or an application side of a theory or an interview with a scientist, tutorial by a subject expert, and more. I had compiled also video clips according to its kind, but I will not show you the videos anymore. I will just give you the title of the different examples of videos. This is an example of animation video. Nuclear fusion, fusion energy explained with hydrogen atom example. This is a physics animation video. You just go to the link below, open it, and you can now see the animation video. You have also a demonstration of an idea. You can do the same. Interview with a physicist, and also tutorial video by subject expert. So, I hope you enjoyed my topics. And please do remember, in every end is a new beginning. This has been Ma'am Deng saying thank you.
Thank you, Ma'am Anna, for your very comprehensive presentation of the single-slit diffraction. Your discussion made the topic easier and more interesting. We are now down to our last facilitator for this webinar. She will be sharing her strategies in teaching physical science. Our third facilitator is a graduate of Master of Arts in Education, major in General Science at Bataan Peninsula State University, with 21 years of experience in teaching profession. Wow! She is a Teacher 3, the Science Coordinator, and the Guidance Designate at E.C. Bernabe National High School. A very flexible and hardworking woman indeed. Join me in welcoming Ma'am Imelda R. Villanueva.
Imelda R. Villanueva of E.C. Bernabe National High School to discuss the suggested teaching strategies in teaching physical science. As the country and the education sector embark on this journey into a new normal, using different strategies in teaching is needed to impart and continue serving our students. Here are some of the strategies in teaching physical science: the video presentation and the mobile apps. A video presentation is a popular form of multimedia presentation with a duration of several seconds or minutes that shows the benefits of a product, service, or any idea with the help of interesting graphic images, concise text, and appropriate narration. Video presentations can take on a variety of formats: fully animated explainer videos, screencast, product presentations, PowerPoint slides narrated by a talking head, or ultimately, the choice of format is yours. The importance of making video presentations. First, persuasive. Video presentations are better able to persuade their target audience through audiovisual storytelling, bringing emotions, sights, and sounds into the mix. Better for information retention. InVisia reports that viewers retain 95% of a message in video form as compared to 10% when reading it in text. Accessible anytime, anywhere. People love to spend time on their phones and tablets, and they prefer to watch videos on them. eMarketer found that 75% of all videos are played on cell phones and tablets. Time efficient. Video presentations are meant to enable the marketer to break down the information into smaller, easily processable chunks. This allows viewers to digest larger amounts of information quicker and easier. There are different apps that we can use in making video presentations. Example is the iSpring Suite. It is an easy-to-use tool. All that required to make a cool presentation is knowing how to use PowerPoint. You can convert a presentation that you've made in PowerPoint, record a separate video, or you can combine the two to make a talking head presentation. iSpring Suite works directly in PowerPoint and allows you to add narration to slides. We can use the built-in video editor to make the video look even more professional with captions, effects, and more. And we can download it for free. Here are the 5 useful steps you need to take in order to make a video presentation. Step 1. Add a video narration. Step 2. Synchronize video with slides. Step 3. Switch layouts in slide properties. Step 4. Customize your player template. And Step 5. Publish your video presentation. And we can watch the video tutorial on how to make a video presentation using a PowerPoint in a given link. Other tools for making video presentations. Number 1 is Camtasia. If you want to create a video presentation but don't have the time to put layouts together, you can use the Camtasia video recorder software. Number 2 is Powtoon. It is an animation, a universal language, and everybody loves it. The service has an intuitive use interface and amazing comic graphics. You can start from scratch or use ready-made scenes and layouts that are editable with the drag and drop feature. The final animated presentation can be uploaded to YouTube, Facebook, and Twitter with one click. Number 3 is Biteable. To make a professional quality video presentations online in minutes, the ability to capture video and record voiceovers for fully animated video. Number 4 is Emaze. If you already have a PowerPoint presentation that you want to enhance, you can import it into Emaze and use its collections of tools, attaching images, GIFs, videos, and 3D images. Number 5 is the Animoto. It is an online video maker that allows you to create video presentations by simply dragging and dropping your own images and video clips into a pre-built templates. To make our presentation even better, we can consider the following tips for creating a successful video presentation. Make your video short and sweet. Keep your video clips long enough to captivate your audience attention, but short enough to incite curiosity. Your goal is to maintain the viewer's interest. Remember, the optimal length is 4 to 7 minutes. Keep to the point. Make your goal and objectives known at the start of the presentation and don't stray from the message. Your text and visuals should relate to the subject matter and not detract from the goal of your video presentation. Know your audience. Explain your content with your target audience in a way that they will understand. Use simpler words that you would in a presentation. Add engaging elements. Enrich your video presentation with useful and interesting content. For example, add music, embed YouTube videos, or insert interactive quizzes. And on a meaningful note, leave your audience with something they can take away from the presentation. And an idea, a visual representation, or even a link to your website works to provide the strong ending needed to create a lasting impression. Mobile apps for science. The advanced mobile apps built with innovative features in fact turn students into scientists. This lets them hold science in their hands and explore it with just a few taps. Smartphones and tablets continue to provide huge potential for science, and app makers are taking advantage of the power of those mobile devices, built-in sensors to create apps for science enthusiasts. Apps will help us teachers and students to explore various branches of science such as physics, chemistry, biology, and astronomy. This list of best science apps for Android and iOS devices will help teachers as well as students to develop their skills by exploring in these different apps. Some sample of best apps for Android. Number 1, Amazing Science Facts. From physics to chemistry and natural sciences, this app brings fun to any lesson. You and your students will no doubt be inspired by the fascinating facts it throws out about the world around us. Periodic Table 2019. This app gives your students a handy table that they can take with them and consult at any time. It's not a static table. You can sort the elements by group or search for them by name. Toka Lab Elements. The app for your class interact with the elements and learn about their personalities or chemical traits in a fun and engaging way. Chemist or a virtual chem lab. Get your students doing experiments in class or at home safely. This virtual lab allows you to try mixing up different compounds and chemicals and see what happens. Students can also try out different procedures and equipment you might not have available in your lab. Physics Studio. Bring the world of physics to life in this virtual lab. Your student can actively engage with experiments rather than just watching them on a video. They can also take a closer look at why things happen the way they do and what that means in the real world. Starfall Catalyst for students. It has all the trappings of popular third-person shooter games, but also makes the player solve chemistry-related challenges. They'll definitely be learning as they play. Earth School Science Games. Earth School app is a teaching about how the universe began and a fun and effective way that it adjusts the right level for them to understand. It has 14 different science games to help learn Earth science with fun sounds and animations. Moon Faces AR, an app which uses 3D visual imagery of the Sun, Earth, and Moon to allow users to practice identifying the different phases of the Moon and to understand why these vary based on location relative to the Sun and Earth. Cosmic Watch is an app that uses mesmerizing and realistic 3D graphics to help illustrate the relative positions and movements of a variety of components in space. It exemplifies the views of the Earth, Sun, planets, and more, all in real time. is a science understanding and application of key concepts associated with electricity topics, focuses on enabling individuals to correctly define the electrical quantities, current, voltage, and resistance. Advantages of mobile apps or lectures. Easy to access anytime, learn whenever you want, learn at an individual pace, many ways to use, easy to deliver, more effective learning, opportunity for self-study, and chance for self-testing. And according to John Cotondana, an American library and museum director, who dares to teach must never cease to learn. This is a big challenge for every teachers. Kaya alam ko po, lahat tayong mga guro ay patuloy sa pagpapaunlad ng ating sariling kaalaman para sa ating mga mag-aaral. That is why we continue to search, to learn through seminars or webinar like this. With that, thank you po at mabuhay po tayong lahat.
Nga naman kahit saan track ka mapunta, mapa-ABM man yan. Even though you're not choosing the STEM, science will get to you. Thank you, Teacher Imelda, for sharing expertise on how or what are the strategies that we should use when it comes to teaching physical sciences. Now, for our closing remarks, pakinggan naman natin ang mensahe mula sa aming chairman, the Teacher 2 from Limay National High School, Ma'am Kristen Joy Matilla. Hello po.
To our SDS, Dr. Roland Fronda, to our Assistant SDS, Dr. Roderick Fallurin, to our CID Chief, Dr. Milagros Peñaflor, to our EPS in Science, Dr. Edwin Bermilio, to all the speakers, facilitators, moderators, PMT, senior high school science teachers, coordinators, and school heads. Good day, everyone. The teaching and learning process is the heart of education, where knowledge, skills, and attitudes are obtained by the learners. In this context, the teaching pedagogies as well as the strategies are very important in delivering quality education effectively and efficiently. In line with this, we would like to extend our deepest gratitude to Dr. Bermilio and SDO Bataan for promoting these types of activities that enhance the capacities of science teachers in the province of Bataan. Also, we would like to give a big thanks to the brains and helping hands who made this endeavor possible. Without you, this journey will not be feasible. Again, thank you very much. God bless and keep safe, everyone.
Thank you so much, Ma'am Christine, for that message and for accepting the challenge of being the chairman for this webinar episode. Being in charge is never an easy task, and for that, I want to congratulate you, ma'am, for a job well done. At this point, we would like to express our gratitude to all the people behind this activity. Thank you for making this possible. To our OIC Schools Division Superintendent, Dr. Roland M. Fronda, to our Assistant Schools Division Superintendent, Dr. William Roderick Fallurin, and to our CID Chief, Dr. Milagros M. Peñaflor, and of course, to our very own Education Program Supervisor, Dr. Edwin Riel Bermilio. Maraming salamat po, sir. Thank you also to our competent facilitators and to the whole program management team. You all deserve a round of applause. And finally, thank you to our dear participants for being with us today. Thank you also, Sir Miggy, for being my partner this morning.
Oops! Before we take our lunch, bago tayo mag-prepare, let me give you some reminders muna. First, we have to answer our evaluation. Kailangan natin yan para ma-improve pa natin ang mga programs natin in the near future. At syempre, kailangan natin malaman ang ating level of retention, level of learning na nakuha natin for this morning. Sagutan din natin ang ating assessment na ipoprovide sa atin on the next screen. Thank you and good morning.